once again be live from downtown Mill Bay.
Why is it downtown?
Well, yeah, because you go uptown.
I know.
So we have to be downtown, by
I
definition.
know. You've said this a million times. That's why I'm asking.
Oh.
This is it.
Well, if you ask me a question, I'm going to take it seriously. It's a serious business uptown and downtown. Downtown. I haven't taken attendance yet, but we'll go with those groups. Get together in those groups, go to the board, determine whether the ones on the front of your page are ionic or covalent. Go discuss, quick. Go, 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 go. Go, 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 go. And then I'll do attendance. And this. Markers are here. They keep cleaning them up on me, which is actually their job. Please answer here or present when I call your name. Aiden.
Here.
Arnie. Arnie?
Yes.
There you go. Bo's not here. Graham? Grayson? Grayson? No Grayson.
Mr. Neufeld, did you take these from Alex or Mom?
Yeah. Yeah. The man tried to play cards in class
Can I get them?
with Anders. No.
With Anders.
Yeah. Jamie? Layla? Liam? Mari? Mari?
None of my group is here.
None of your group is here?
Yeah.
Join Rachel then. Oh. Join them anyway. Matthew?
Yeah.
Miyabi? Miyabi? No. Nick?
Yeah.
Of course, I just talked to you. Noah?
Yeah.
Rachel, of course. Rose, yes. Violet? Violet? No Violet. Yuma? Excellent. Once you think you've determined for all of them, have a seat.
Oh, I did.
Ah,
And GSO. Because you're talking about it.
Mario, I will now mark you as present.
Thank you.
What happened?
Oh, I just wasn't ready to touch
All right. Present. Join a group. You were Nick. Your group is now here.
Oh,
Determine if they're ionic and covalent, and then have a seat.
And also too long.
Oh, now, I want you to think, because obviously we're going to go over, are they ionic and covalent? But what are the rules? What rules did your group come up with to determine if it was ionic and covalent? Yes.
Is it not like a metal?
Okay, that's one rule. Don't keep saying. So one rule, metal. Any exceptions to that rule? Do you think of an exception? No. Any other rules? Yeah. Has. Explain what, because yes, you are getting to the heart. It has to have an ion. But what do you mean by anion? Negatively charged.
Sorry, cation I meant to say. And yeah, it has a positive, I guess, it's a metal.
Can you give me an example of what you mean other than just a metal?
Well, a
So that's the same as that. That's the same as metal. It's clever because there is one that isn't. Yes.
Metal and non-metal.
Metal and non-metal. So that's the other piece that's missing. Anybody have any exceptions to that rule?
Hydrogen.
By itself? Who said that? There. Why hydrogen?
Because it's both.
You're almost too clever. HCl looks really ionic, and in fact, if you put it in water, it separates into Cl minus and H plus, just like a metal would, and you go, oh, it's ionic. It's not. It's covalent. It's so weakly covalent, water can rip it apart. So hydrogen isn't the exception, although you're kind of on the right track. Yeah. Ammonium. Is this ionic or covalent? That is ionic. What's ammonium? It's got a positive charge. This, whoops, because this goes right to what you were saying. This is a cation. It's a polyatomic cation. And so ultimately, all you need is a cation and an anion. But that gives another clue. What's the other clue? Like, without even looking that magnesium is a metal, I know that this is ionic right away. Why? What does it have? Yeah?
3.
It has 3. And what is it that gives it 3? What is the name of that last thing?
It's a polyatomic.
It's a polyatomic. So if you have polyatomics, that probably gives you a clue as well. And so if you see a recognizable polyatomic, that probably goes. So let's just check what people have said. Number ionic, NaCl. Yep. I'm just going to write I or C from now on. And MgSO4 is ionic. And then you have CO2 being covalent. And H2O, dihydrogen monoxide, being covalent. And N2O4 is covalent. But sadly, did every group put NH4Cl? That is covalent? Yep, 1, 2. Everybody did it. So, one of the reasons I have you memorize your polyatomic ions is so that you recognize that. So this is actually ionic. One of the reasons I'm doing this first is we're about to do covalent naming. When I started ionic naming, a few of you said, oh, monodi-tri, and I said, no, God, no. We didn't do that in all of ionic naming. So if it's ionic, you don't do that. But now we're about to do that, and I don't want you to get the two confused. So we're going to try and keep them separate to make sure you don't get confused. Not that one. Not that one. This one. I did waste almost an entire piece of paper. This goes, and then it has, I didn't notice, it has but 2 lines on the next page that it actually didn't even need to do. And then the answers are given the 3rd page. So I destroyed an extra tree for you. You have, let's say 4 minutes to do this. Oh, I'll write it around. The answers are on the back, so you can check it. But don't check it question by question. Check it like every 3 or 4 questions. And then if you keep getting them wrong, call me over. You have the stuff up in front of you. Put those worksheets away. Where is it? Where'd my phone go? Hey Siri, set the timer for 1 second.
What?
No. There it is.
Oh my god.
Have you ever asked Siri where you are? Like, where are you? You know what it does? It says, I'm here once. You can never find it. But if you say, set the timer for 1 second, it'll count down and then ring, and then you can find it. We've already been going for 30 seconds. Hey Siri, set the timer for 3 minutes.
Tin is
And
it's a metal, right? What is that?
Learning the staircase one, well done. Data table? So you can tell metal from non-metal?
No, we're just like on freestyle. We were freestyle.
It's done where? No, you need your data table. There's no data table in there, like your data table. Here. I will give you a new and old data table. Which picture do you want? Oh, you can use that one. I'm about to make a brand new data table. It's going to be an updated edition and I'm adding more information. If you have a picture that you think would go well in it, I'll make an assignment, bonus marks, or the most AI sciencey thing you can generate. I will pick the best one. Question? You were staring at me in an expectant way, so I was like, here we go. Yes. Which word? That word? Oh. Let's see what the computer thinks. Oh. Cation. Remember, cations are
What do you think it's gonna say for non-metal?
positive because they have paws. They're cats. Remember? Positive. You don't remember.
I remember.
Oh, excellent. Well done. Okay. Okay, put that sheet away. Is there any on there that you have a question about you couldn't do? You can finish it off later. That was just to make sure that you got that right away. Okay, add these in. So an ion is a cation and an anion. That seems weird to phrase it like that. I'm going to say an anion. That makes the English work a little bit better. Which is often shortened to a metal and a non-metal, because those are most likely cations and anions. However, it can be a polyatomic and anything other, and those polyatomics can occur in any order. You can also get double polyatomics. So NH4 bracket 2 SO4, ammonium sulfate is certainly a possibility as well. But if you see a polyatomic, and just be on the lookout for ammonium. Now that we've all done it and we've seen like, oh yeah, this one's tricky, now we know it's tricky and it can't trick us again. Covalent is only nonmetals. We're going to be learning how to name them today, but we're only going to be learning how to name them if they are two elements. So binary covalent compounds. And you already know how to do it. Is what I like about it. I am going to ask people at a random. So Graham, first one, CO2, what is the name of that? That's carbon dioxide. Well done. You know how to name, we can all go home. Nick, if that's carbon dioxide, what's CO3? Say it again. Carbon trioxide. Excellent. So, Liam,
Okay.
CO4,
What's it? Carbon tetroxide?
carbon tetroxide. Now, we would, if I was being, it would be tetraoxide for any other second one. And if it was nitride, it would be like CN4, it'd be carbon tetranitride. But there's a rule in English that says when you have those two vowels together, when we speak it, we often drop the A. So it's actually tetroxide. To be honest, I'll probably accept it if you say tetraoxide, but we also want to be correct. So tetroxide, you said it correctly. Jamie, on that logic, what is CO5?
Carbon pentoxide.
Carbon pentoxide. See, this is the easy naming system. Next one you actually already know as well. It's a very deadly gas. Aiden.
Monoxide.
First part.
Monoxide. Carbon monoxide.
Well done. So carbon. Similarly, we would normally say mono and then whatever it is. But when you say it's not monooxide, same rule in English. When you have two O's, we drop the first O. So it's... And I say it's a rule in English, and then a bunch of people brought me a bunch of words that do have two O's together in that kind of a way, and I'm like, I don't know. English is weird. It's not a real language. It's a bunch of different languages dressed up in a trench coat pretending to be one language. We take other languages down a back alley and mug them and steal their words.
Oh.
Yeah. Explain kernel. Sorry, that's one of my pet peeves. How do you spell kernel? Yeah, there's no R in that. I only learned that kernel was spelled that way last year. I thought colonel and kernel were two different words. Someone's asking. You pronounce that kernel. Because English deserves to be a great big smack across the head. Because the derivatives is from a French word that used to have an R, then lost it, but English kept the French pronunciation, but the English spelling. God. That's why I like to go to the dining hall last night, and I had tortillas with my jalapenos. Matthew, C2O. Dicarbon. What was the last one? Monoxide. Drop the extra O. Now, notice, two carbons, you automatically did it, so we put a di. But one carbon, but we don't have mono. We never put mono on the first one. No mono on first one. Nobody likes mono, so we want as few of them as possible. When I was in grade 4, a girl came back to class and we were all given a long lecture on how we weren't allowed to bully her because she had mono. And we were like, bullied her because she had mono. And then the teacher explained that mono is also known as the kissing disease. So after that, before that, we didn't know. We would never have made fun of her. But after that, we were like, she got the kissing disease. Sometimes teachers do things that are stupid. Maury. C2S2. No. Look. When it was C2, so 2 is di, so C2 would be dicarbon. And then, what is just S? Yep, and when it's second, it would be sulfide, and you have 2 of them, so disulfide. Do you like your sulfides with an F or a pH? Okay. There we go. Did I give you a copy of the notes after you asked me?
No.
Yeah, okay, that's my fault. Oh, someone also left one up here. Does anybody not have one? I'll give it to you. Okay. I'm going to ask you to do these, but I'm going to make sure everybody can count first. So, what is the word for 1? Mono. Because everybody rides their monocycle. Word for 2? You ride around town in your bicycle. 3? Tricycle. 4? Tetra. We don't actually have a tetracycle. But Tetris comes from the Russian word from 4, which comes from the same root of tetra. And it is a game in which all of the pieces are everything you can make out of 4 blocks. So it's based on the number 4, which I always thought was cool. 5, penta. Yeah, it's I remember it as the shape that math teachers do their spells in. Pentagrams. 6, hexa. You cast a hex on someone. Coming from the word, coming from their original idea of the number of the beast being 666 or hexa, hexa, hexa. Turns out our earliest translations of the Bible now show that not to be the number. They changed it at some point. Maybe to stop people from knowing what the number was. Interesting. Anybody know what 7 is? Yeah, hepta. If you're in French or know French, you'll know it as sept. It comes from the same root. You just change the first letter. 8, we've got an ocean creature. Octa for octopus. I do not have an example for 9. If anybody knows of one, it's Nona. And someone said, Nonagon. I'm like, yeah, that's a shape with 9, but nobody knows that. If you can think of an English word that works in 9, there is one, but it doesn't make any sense. So I'm always hesitant to mention it. But since we're actually in it, I probably should. November, nov, means 9. Comes from the same root. Is November the 9th month? No. What's 10, by the way? Deca. December. Deca. 10th month. Is December the 10th month? No. October. 8? Not. They number perfectly. And then, like, I think one of the Caesars was like, I went to my own month and invented Augustus. And they ruined the entire numbering system. Deca, we do have a common one. It's decade for 10 years. And so those are all your prefixes. Pull out your data table. Can you find this list on a page in your data table?
Yes.
Yes. So now that I made you write it down, you technically have it. However, if you have to look up every single one every time you have to name something, that would take you a really long time. Highly recommend you memorize it. But it's there if you just like, oh my God, what's 9? You can just look it up. So it's there for comfort, but it shouldn't be there for every single one. You should know the majority. Okay? Now go back. What? How long? What do we got there? 1, 2, 3, 4, 5, 6, 30 seconds each. 3 minutes? 3 minutes? Aiden, 3 minutes to do those? 30 seconds each? 4 minutes. Sold. 4 minutes. And then I will call out people. In 4 minutes, I'll just start listing names. Come up, first come, first serve. Fill them up, only 2 at a time. We have 2 pens. I still have one of the pens from the other TV. Probably shouldn't have said that.
Oh no, I just spelled it flower red.
Don't spell the flower line. Excellent. This was done last year, Meta, right? I think the main problem is just mixing the two up.
What do you have for first one?
What is 3?
Trioxide.
Well,
Tri-
3 applies to the
Carbon. Tricarbon.
tricarbon.
Yeah.
Yeah, yeah, nice and good. You did. Careful on that one.
Which new phone is this, right? Oh my god, I spelled corn.
Sorry. We called that one copper. Yep. Try it. Yep. Yep. Yeah, chlorine. Did you? I took for it. Someone did. No, looking good. Excellent.
Only
What
when
is
you
it?
have
What
like
is
an
it?
A and an O next to each other that you just erase
And
them.
when it's second, it's not
It's like
fluorine,
for like
but
oxygen,
for
oxide,
ions.
tetra.
The second one always has.
Tetra.
Yes.
And also potassium.
33 seconds.
Like what you want.
Last little while I've been repeating this setup. How do you like this one? 3-3-3, it's 3-3-3. Is good? Yeah? Would Matthew like that? I'm a big believer in not doing things to birthday people that they don't want. Pardon? Which sheet? With this? Listen, Matt. Which sheet are you talking? That one is these. Oops. These two.
Okay, wait, 7. Hey, you would like that. I would like that.
Oh, okay. You understand that side? So what is 3? What is 3? No, no, no. In terms of pull your data table. And then reason. And then call 4 people up to there, and then do the second one, and then show them. Yuma. Arnie.
Yes.
Rachel. Noah. That's 4. Layla. And Aiden. Whichever one isn't done by the time you get up there. First come, first serve. 2 people can write at a time. Now just do that. They're all the same. There's no easy.
Did you do it? I know it.
And I can help you up there for anybody who gets up there and goes, oh, they took the one I wanted to do. Yeah.
Why did I forget how to spell corn?
What do you mean? I know how to do it, man. Thank you. Alrighty, which one are we doing? Why? What do you mean?
Because then you can.
Ah, I see. Alright. Oh my god. What does that say? Okay, ready? I'm doing.
No, chlorine. The first one never has I, but the second one always has. So same as the
Move,
one
actually,
part that
actually.
repeats is for
What does
like
that
I,
say?
the second one's always an I.
Votetra.
That's good. And this is just English. ECAO.
Tetra oxide.
But I probably
That's oxide, bro. But these are so cool. It's kind of delayed though, ready?
Yeah. Who said Mr. Newport? You get a special handshake?
Yeah, it's good.
Oh. I just find that odd. Someone that's like too firm of a handshake and it's like,
It's like showing you.
yeah, and it's like, what are you doing? What are you doing? I'm a chemist. I can poison you at any time. Like, it's not about strength. There's a cupboard in there, less than a gram of one of the substances, everyone in the school. However, that sounds like an amazing claim. It's not. There's lots of chemicals like that. You could hurt everybody in the school quite badly with just what you can buy at Thrifties for not very much. If you have access to bleach, you have access to one of the most toxic substances known to humankind. Do not mix cleaners together. Someone, and I'm mentioning this because someone was just hurt very badly in Canada, not like nearby, but out in Ontario, because they mixed an ammonia and a bleach cleaner together because they wanted to super clean their kitchen. And they released both amine gas and a type of chlorinated gas. People always call it mustard gas in the news. It's not mustard gas, but the difference is academic when it does the same thing to your lungs. They luckily didn't die, but they will be recovering for months. Their lungs are very badly damaged.
They like wrote on this like bleach thing in like big letters, do not mix with Mr. Clean.
Yeah, you need to be very careful with bleach. My aunt had to remove it from the house because her kid was too stupid. He ate everything. Like literally, he would crawl and he would eat everything. And about the 4th trip to the hospital, after he ate some cleaner, the doctor just said, remove all the bleach from your house because he can clearly get into everything. They had everything up high, but he would figure out ways. We can't save bleach. We can save probably from everything else, but get rid of all the bleach. And so they did. And now he's like, I don't know, in his 20s, and he seems relatively normal. I don't know if I believe it yet. Okay, opposite way. Take the name, go to the formula. Oh, hold it, I didn't check these. Look, how confident was I that I just assumed you were right? Tricarbon tetroxide, good. Chlorine hexafluoride, great. Sulfur tetrafluoride with a really messy "ide" there, good. Diphosphorus heptoxide, lovely. Dinitrogen tetra, that should say oxide. I'm a little weary about your D there. Leery, not weary. Dihydrogen monoxide, which is technically incorrect. Dihydrogen monoxide is a deadly chemical. We find it in acid rain. It's the chief ingredient. We find it in every cancer we've ever biopsied has had dihydrogen monoxide in it. Prolonged contact with a solid form will cause tissue damage. Prolonged contact with the gaseous form will cause heavy burns. What is H2O? Water. The technical name is actually water. So there's a few of these that have their own little name. One of them you're going to have to memorize is water is water. But if you call it dihydrogen monoxide, I'll chuckle and accept it because I think it's cute. Do these ones. Go to name to formula. I will call up 4 people again. Aiden.
Yeah. Alright, so you do P4O10.
Oh, cheat. I was just going to ask you for the amount of time. Like 4 minutes, 3 minutes.
I just did
But
that.
you just
I
did that.
in my
You
head.
just did that. I'm just going to call people up. Yeah. Where did I put all my pens? There they are. So, tetra, 4, P, deca, 10, O, P, 4, O, 10.
Yay.
Where's the pen? I'll give you, like, as long as it takes me to find my other pen. Did someone take it back to their desk? No, I just had it in my hand, didn't I? These are long, there it is. Okay, coming up to do these. Where is, there's Class Dojo. Jamie. And Rose. And Noah. And Layla.
Yeah, you only need 3 people. One's already done.
Oh, right. So the last one to go gets to choose if they want to go, I presume. There'll be a fight for who's the last. No, that won't work. Excellent. NBC. Before you come up, if you ever want to check with me if it's correct, you always can.
Fuck it, just take that one. It doesn't really matter. Is that even?
Beautiful.
Is that right?
That's beautiful.
Is it beautiful?
It's beautiful. It's beautiful. Okay. Stop talking about Fortnite.
My ATLs are like, it's like, what's a good ATL?
Habitually?
Yeah, I'm habitually in every class.
No, you're not.
Nice.
No,
Don't
I'm
argue.
Mr. New, I was pretty good except for this class.
Oh, that's good.
But honestly, Baker, you want to see?
No, we're not arguing about ATL. We're doing chemistry.
I want to play on this like little Xbox. You know?
Right now?
No, we get
No, ATLs are going down if you're going to do that now. I once caught 2 boys playing Counter-Strike in the middle of class between each other. I took away their computer for like a month. They were in my house. Okay. Okay. One thing I want to go over with all of these that you don't do here that you would do in ionic. So if, for example, in ionic, we had Ca plus 2, O minus 2, you crisscross, and you get Ca2O2, what do you do with that? Yeah, you reduce it. But we don't reduce it here. So only ionic do you reduce, never covalent. I made my L have a T, so that doesn't work. Covalent. The reason being is that calcium oxide is CaO, CaO, Ca. It repeats forever. So like calcium 10,000, oxygen 10,000. So this is a ratio of the charges. This is actually what it looks like. So O2F2 is very likely to be something along the lines of O double bonded to O, F, and F. It is actually O2F2. You wouldn't reduce because that explains what it is. Whereas if we had H2O2, hydrogen peroxide, it looks like HOOH. I'm just scribbling on the board now, but it's there. But OH would be an entirely different compound. In fact, OH minus exists, that's hydroxide. So in covalent, if they have numbers, even if you can reduce them, leave them alone. That is that compound. Whereas because ionics are just ratios, you can get rid of them. So and no mono in the first element, no double O's, never reduce, no AOs. We also get rid of those. Next section, I'm going to skip around a little bit. There are three ones you have to just know. They don't go by their normal name. One of them is dihydrogen monoxide, which isn't dihydrogen monoxide. I've already told you, that's water. Another one is CH4, which is methane. I've already, I think, talked to a couple people about organic naming. We are only doing 2 elements. If you have C6H12O6, what's that?
Sugar.
A sugar. That's specifically probably glucose. But we wouldn't call it hexacarbon, whatever the Latin number for 12 is, hydra. Does anyone know the Latin number for 12? It's dua something, I think. And then hexaoxide. That's glucose. There's an entirely different set of naming for all of organic, and we're not going to do that. So covalent naming actually has much more complexity than what we've done. We're doing very simple binary compounds, but CH4 belongs to a separate set, so you should know it's not carbon tetrahydride or whatever, it's methane. So if you see methane, you just have to know that one. And the last one is ammonia. Very common chemical. You'll see it in lots of cleaning compounds. Definitely do not mix this with bleach. This is one of the ones that will react with bleach straight away and give off both a mustard gas-like compound and an ammonia gas-like compound. If you're ever working in an area in which there is lots of ammonia and you suddenly stop smelling ammonia, it smells a lot better, run immediately out of the building because it burns out your ability to smell it at about the time it becomes lethal. That was the safety instruction I got when we were working at a giant factory that had huge vats of ammonia. Is if you ever stop smelling it around here, get outside as fast as you can. But it's a really great cleaner. It's a mild base. If it's just on your own, you don't set it near bleach, it's fine. It's great. It evaporates away. It's perfectly safe. We used to use it in baking. We don't anymore because we have stuff that smells better. But yeah. There's another one that looks a lot like it and has a very similar name in your polyatomics. What is it? Ammonium. So NH4 plus is ammonium. So they are not the same thing. They are different compounds. That one has an extra hydrogen and a positive charge. Do not mix them up. And to help, I don't know, this is what I used in university, was this one. Longer name equals bigger because it has more H's. So the one with more H's has the longer name. If that helps you, that's great. It's also handy that ammonium is on there because then you know, oh, I take away an H in the charge and it becomes NH3. That's not ammonium, that's ammonia. Helps you remember the name. All the other ones are also names. The ones in bold are the ones I'm saying you have to memorize. but like phosphine is pH3. Not going to ask you to memorize it. These are not dihydrogens. They just traditionally are just hydrogens. And these are only named this if they're gases. And we don't call them monochloride. So just so that you have a reference if you see that anywhere else. However, if HCl is in water, does anybody know what that is? You're walking around with a sack of it right now. HCl.
Oh,
Biology.
it's salt. It's like salt water.
It's, you can make salt from it. HCl and NaOH make sodium chloride. It's an acid, and it's the acid that's found in your stomach. So hydrochloric acid is HCl. So when it's not a gas and it's like in liquid and it's become aqueous, it's hydrochloric acid, a really strong acid, and that's what you use to break down tendons and proteins and all sorts of things to help physically break apart your food. We're going to skip this. We're going to skip that. We're going to skip this. And, hold it. Why is there writing here? And we're going to go to elemental gases. Skip ahead. One, two, three, four, five, six, seven. The elemental gases all have their own special name. These are the gases as they're found in nature. So we never find hydrogen just by itself, monoatomic. We always find it in pairs on planet Earth and in most of the universe. So H2 is called, does anybody know? It's just called hydrogen. So what is N2 called? Nitrogen. And so I am doing this to be very pedantic because it's really when students go this way that there can be problems. If you see the word oxygen in an equation, it doesn't mean O, it means O2 because we never find oxygen as O. And planet Earth, if we say there was oxygen, it was always O2 because that's what's in the atmosphere around it. This is what's in the atmosphere around up. If there's fluorine around, and God, I hope there isn't because that would burn out your lungs. But if there was, it's F2. So these are all the diatomic gases. They all are just called by their elemental name. And if they're just say fluorine, it's always F2. Now they should say fluorine gas, because that makes it a little bit more clear. But even if it wasn't a gas, iodine is a solid at room temperature, and it still exists as dimers of I2. So this is solid or gas. Iodine is kind of nice in that you can heat it up and it'll go straight from the solid to the gas. Chlorine gas. And then I'm going to draw a line for the acids. HNO3, H2SO4, H3PO4, HCl, H2CO3, and 2, 3, 4. Oh, right. CH3COOH or HCH3COO. There are 6 acids that you have to have the names memorized. There is a trick. The trick is, if I just gave you NO3 minus and you looked it up on the polyatomic ion, what is NO3? Nitrate. all the 8s, when you add a hydrogen to them, become ic acids. So this is nitric acid. That would be sulfate. Add some H's. Sulfuric acid. Phosphate. Add some hydrogens. Phosphoric acid. We're going to do types of reaction. We're going to do a little bit more on acids and bases. And after our cross-grade exam, I want to do a lab on acids and bases. Yes?
Is the second one A2 or is it H2?
This? Oh, all acids start with H. Acids are compounds that give off H+. So they have to have H somewhere. This is hydrochloric. HCl, the one in your stomach. This, a very important one, is carbonic acid. You use a version of this if you take the bicarbonate, HCO3, put sodium on it, and that's how you get the bubbles inside your cookies when you add baking soda or baking powder. It's also involved in dissolving CO2 in the oceans. As the oceans, weirdly, the warmer the water is, the less it dissolves, which is kind of the opposite of most things. So as our oceans get warmer, they're actually releasing more CO2, which is not helping things. These are both the same. And this is acetic acid. Also known as ethanoic. You will almost always see it as acetic. It's one of those old names that never goes away. Everybody knows their nickname. And everybody's forgotten their real name type of deals. No, come down. But also, students will ask, well, why isn't this C2H4O2? And sometimes really silly inorganic chemists will write it that way. Also, you'll notice all I did for this one is I moved the position of the H. The reason it's written this way is it literally has that structure, and it's a biological compound. And when you have that structure, by writing it in that way, we know which hydrogen comes off, and we know the structure. This compound one, two, three, four. These are both C2H4O2, but that one's acetic acid, and that is a weird aldehyde alcohol. Ethanalol. Ethan2al1ol, if I was to name it according to its proper formula. That maybe came close. Probably got my numbering wrong. These are both the same formula, and so by writing it this way, we can tell the difference. You don't have to worry about any of that, but it does mean it has a completely different naming structure. And so when we write it out, we actually write it out that way specifically to show. Some people write the hydrogen in front to fit all the other acids, but a biochemist will write it afterwards because that's literally where it goes. You'll see it both ways. Now, I said you had to memorize those. I am changing your periodic table to add those 6 to it, to the same page that has all the other details. So if you forget one, you can also look it up. But again, if you know what phosphoric acid is, you'll be a little quicker. I don't want you to be aware of those, but you'll have a list of them on the test. It is 11:19. Let's see. You can now do, in this worksheet, up to number 5. Before you finish this off, I have a sheet of just practicing binary compounds like we did right now, covalent, with the answers on the back. Do this. If you're doing well, finish off this. Yep.
I think I gave it to you for like a test, but I don't
Right up here. Check. At the end of when everybody handed in, I said, take it with you before you go, but a ton of people didn't. I think most people were more focused on what. Yeah. All the chemistry.
Why was it on the worksheet?
Everything.
I wasted all my time.
Well, you have a review packet for the first concept, and for like all of these, you have like I'll put something together for the weekend. But we're gonna do, we're still gonna be doing some new material.
December 26th.
And on Saturday. On like Thursday or Friday, thanks for us, it's Friday. 21st or 22nd, whichever day we have class. I will have a review class ahead of time. So usually the class ahead of it, we don't do anything new.
Can we start on it?
Yep, start. So do the one I just handed out first.
Majority versus minority.
No social studies. No social. No government. This is a government-less zone. We are anarchists.
What?
We're chemists. We throw like gasoline in bottles and stuff in handkerchiefs and light them on fire. No, we don't do that. That would be wrong.
That's called, isn't that a Molotov?
That's a Molotov cocktail, yes. If you're getting this one right, go through, then finish off this one. You can now do to the very last page.
Like an octopus with these ones.
What time does this class end? We have, give you about maybe 10 minutes or so. We have Thursday and then we have Friday.
Oh, we keep that.
And then,
Okay.
excuse me. I will need to get the Ghost of Halloween.
No, but I think that's fine. Oh, we have a demo.
No.
No?
I'm even talking about your working file. Oh, does it take time to? And on the buttons on too. It does. Because they said, oh, we improved it, and we flipped it around, but then it wasn't, they weren't working. I wonder if that process was broken and they had to flip them back around again. It takes longer. Oh, this scratches this table badly. I don't know. It's, yeah, it's not thick. Good.
always use the lap notes if you wanted to.
Oh, okay. And then, oh, it's going now, though. Nice.
Gradually hasn't used our weed get sucked up.
Excellent. So you can have your other worksheet. I'm finishing it off.
Other worksheet?
Yeah, 1 through 5. One, it looks like this. Oh, Matthew. No? Yeah, everything. It was just for me to look at to see what prep work he was doing. And to see whether or not he marked them. No, well, you have the answers in the back. Mark it. Mark it. When you're done with the first worksheet, mark it. No, Mark, you're just making sure that you know how to do it. And if someone doesn't have a copy of the worksheet, I do have more. Oh, so many more. Is there anybody that doesn't have one of these?
I'm just looking for it right now.
Okay.
Oh, yes, I have a copy.
Yes, you need.
I'm not very far in it though.
Have you done this one? You done it? Okay, and you check your answers. You good? And you've got the worksheet package, number 1 to 5. Well, here. You can start working on whatever worksheet you know you have it. All done? Done this? If you get news that you're like, grandmother died, then yeah. But if you're just like tired, it's like, go better. You were done? Show me the worksheets. The worksheets look like that? Yeah. Oh, then it's not done. Worksheets? Pull your work, pull your notes. If you don't have them, I can provide you with new ones. Really? Oh, I do not think so. I think maybe. Oh no. Well, you can snap it. Nick, I'm talking to them. They have to work. Where's your work? It looks like this. Yeah, so you're either working on it or working on it. Yeah. In your room doesn't mean you're done. Pardon? Excellent. Don't talk to them though, because they are not done. You can start on page 5, which is what we did today, and then work forward. Katie? Start on page 5, which is what we did today. Oh, I might have said Katie. Yep.
Yes, I do.
No, polytronics never. Ammonium's never. Iron is not polytronic. The 2 applies to iron. Iron does too. Well, because polytronic is so the polyatomic there is iron is iron 2. Iron plus 2. So you're doing some that one with it. Some you don't have room with it.
I haven't worked like scattered.
yeah, they'll be positive hydrogen and but the polyatomic itself.
You know, like you can have this
Oh,
behind.
but we have 3 periods also in alphabetical TE to very 52. Then you can go back to it, where is 52? And now that you know it's 52, because they're in order, that's the atomic number. 52. Go on. You have strength and character to ignore him.
Oh, I'm not even.
Yeah, not even talking. Stop bothering him. Yep. It could be carbide, yeah. Second. Yep. Mm-hmm.
What will it take for you to unlock the day surgery forever?
People stop messing it up all the time.
It was clean.
Yeah, no, it wasn't.
What?
You guys have day students.
Who uncleaned it? I literally vacuumed it every day.
Yeah, and then other people go in there.
It's so lame. I
You
spent
guys
like,
get day
I
students.
spent like 30 minutes cleaning that room.
We have to share our rooms.
No, we're just special. We get a day student. I know.
Okay, put away your worksheets.
This is for one day.
Next one. Another one.
We're doing it today.
Yep. No. All classes are like 80 minutes. Okay. Worksheets away.
Nothing.
We're going to be doing the 6 different types of reactions. We have decomposition reactions, and that's the one for which I will have a little bit of demo in a moment. We have synthesis reactions. If you went to a different school, you might know that as combination, if you've seen it before. We have signal replacement reactions and double replacement reactions. Occasionally replacement is replaced itself with displacement, so single displacement and double displacement. The exact wording is not terribly important. But they're a type in which an element either switches partner with another compound, or if it's double replacement, they both switch partners. And then there's a very special type of double replacement called neutralization. Or we just call it an acid-base reaction. And then we have combustion. Combustion reactions, we're only going to look at carbon combustion. We're burning organic things like paper or wood in a fireplace or anything like that. Combustion can be a lot of different reactions though. Plastic can burn. A lot of theirs carbon, but we can get sulfur to burn, which no carbon involved. But we're going to limit ourselves to just normal, fire burning type of combustion So that's the overview. There's one special type, which is really just a type of double replacement, but it's unique enough. Acid-base reactions are important in their own right that we recognize it as a separate type. The first one is the decomposition reaction, in which you have a something like this, like a compound is broken down into individual elements or smaller compounds. And I am going to go grab the demo for this.
Probably. What's this name? Is this smelly? Small. Smelly compound. You can, but she says they don't actually have to do the pencil anymore because it's kind of stretched out for a while in the water. So we just kind of have to like she doesn't want us like reading it like this, like and then have like a maybe like a picture or something like drawn like or like printed or something like guitar. Mixed up with Seth.
Okay, for the first demo. Yeah, and I'm wondering why people have their books put away. The bell hasn't gone, and you will not be excused if you've already cleaned up. This delays the class, and delays showing things. We go right to the end. Every moment of learning is precious. This is actually the spirit of Halloween that I trapped inside of this glass. I managed to stopper it inside. You can see there's a little bit of water at the bottom. And if I pull the stopper out, I will release the ghost of Halloween. I've got that on. I want to make sure once I've released it that we retrap it into the system. Yeah, excellent.
What are we looking at here? Wow.
Show it reacting to the bottom. So you see there's something rapidly going on. And of course, the ghost of Halloween being released. The demo, if you look it up online, I think it's called Releasing the Genie, because you can release a cloud of smoke. It is a rapid decomposition of hydrogen peroxide. So the other example, now this one is baking cookies. You add baking soda, which is what this is, sodium hydroxide, or sodium bicarbonate, or bicarbonate of soda, which is what you'll see sometimes labeled. Before you go, please write down this reaction. And then once I've seen you written it down, you may leave. Good, go. Go. Yes, and yes.
There.
Yours. Yours.
I don't have to wait for it.
Pardon? I handed it out, it's right in front of you. So the next page.
That's my nickname.
Hayden, I didn't see yours? No, that reaction on there. Going. Right, take it out, write it on. In the right spot. No, I don't need to see that, I need to see that.
Do we turn it off?
Right, no, you don't have to turn it yet. It's a note that you handed out. Good, good.